Good evening, everyone. I would like to welcome our speaker, Sachin Sakore. Sachin Sakore is Senior Manager at Voice. Sachin would be delivering an interactive talk session on AI-driven cross-browser visual detector XB-VDD. To know more about Sachin, please check the below link. Sachin, over to you.
Thank you, Divya. Good evening, everyone. First of all, I would like to thank Team ATGTR, Aditya Garg, and entire team for creating such a nice platform and giving opportunity to AI enthusiasts, all the technology experts to express their views through these virtual sessions or maybe face to face, which is planned on upcoming December month, 14th December. So thank you again.
I appreciate
So
your presence, Sachin. Thanks, and
thank
we
you.
are very grateful for all the speakers to be part of this wonderful conference. Thank you so much, Sachin.
Thank you, Aditya. So this is my second attempt. I think in the January month it was face to face. I have attempted in the Gurgaon Nagaro. So at that point of time, it was a really nice experience I had, and this is second attempt. So thank you again for selecting this particular concept, a thought, which tuned in my mind, and I'm just presenting this. It is not a formatted framework or a tool, but a thought which came in mind, which is we are experiencing on daily basis. So thank you. So this is beautiful Sunday evening, a weekend, and everyone has spent their precious time for this. So thank you all the audience for your patience. And let me start with the details which I am going to present. Let me share my screen. Let me know if my screen is visible. Okay, let me share. Okay, I hope my screen is visible to everyone.
Yeah, it's coming up now. Yes.
Okay, I'll just put it on the slideshow. Okay, I hope the slide is visible to everyone. AI-driven cross-browser visual drift detector XB-VDD. Okay, so prior to start with this, I'll just give some flashback details on this particular part. Maybe we can consider like if we see any particular movie, and before we jump into the action scenes, there are certain flashback. There are certain themes associated with that particular action. So why this particular aspect come in my mind, and why I come up with the XB-VDD thought as a concept which can be implemented, and by implementing the same, how the industry get benefit out of it, because there is a lot of potential to improvise on the front end related part. So I'll just highlight few details prior to start with my presentation. That couple of years back, one of my development friend came to me and he has highlighted like he has spent a whole night to develop certain things on particular browser based application, and it got failed. So I have just neglected that. There was a complete ignorance from my end, and I thought like, why should I focus on it? So at that point of time, he was very fed up with that particular work. And the next day, there was a team meeting, and the question was asked to testing team. Obviously, it is to the QA, and there is a obvious statement came from the testing team side, or maybe from the QA side, that yes, it was working on my machine, and when it was tested on the staging environment or in the testing environment, it was completely fine. See these screenshots, these were perfectly fine, it was working fine. So these were the answers. Everyone, maybe those who are QA, they have experienced all these details, and they have experienced all these at some point of time. So just to highlight, like, these are certain drifts we are experiencing on day to day basis. Okay, there are certain browsers we are utilizing. There are Chrome browser, Safari browser, or Edge browser we are using. On different browsers, we are experiencing certain details. With respect to that, we see some visual drifts. Okay, so with respect to those visual drifts, we are experiencing like there are certain changes on the page, on the UI, or on the that particular web, and it is creating certain impact, and that is a visual impact. Okay, so uh, just to highlight like a shocking or the surprising part here, like the recent industry study has highlighted that apart from the functional uh, breaking point or the functional issues, these visual issues, that is UI related production issues, are also creating a major impact, and there is a lot of potential losses are associated with it. and that is due to a pixel shift or maybe a misplaced CTA, a font rendering change, a button which is getting overlapping on the banner of a particular browser. Okay, so this issue isn't limited to any particular domain. We are having so many domains in the industry like the BFSI, e-commerce, health sector, likewise. And within those particular domain, we experience these particular details at many a times. It cannot be ignored as well. Okay, so if suppose we can take an example of a healthcare sector, if a doctor misread a particular column sequence on a particular web page which is related to the patient, okay, maybe it is not causing any as such harm to the patient. Okay, there is no medical harm, but thankfully, even though there is not a particular harm to a patient, it triggered an emergency to have an audit across the particular platform which is displayed on the web page, as it is producing a certain different values. Or maybe we can take an example of an e-commerce site, a product price which is rendered as $999. However, instead of that, it is getting displayed as Indian rupees 999. Huge change and huge impact on the revenue as well. So if suppose a certain browsers are showcasing these particular rendering differences, then definitely there is an impact on sales getting dipped, the customer trust is getting dipped, and a support calls are getting exploded like anything to resolve those particular issues because there is a revenue loss for a particular organization. Okay, so now, if we see on these particular problems, we see like prior to launch of any particular web application onto the production, we see like there are certain test cases which we have considered, those are passed. We have certain automation test suites which are passed. The functional validations are also passed. But even there is a pixel difference tools which through a thousands of false alarms, and those still miss the meaningful drift. Those are the visual drifts, and because of these are not the functional defects, but because of this, we can see the visual, semantic, and cross-browser rendering inconsistencies. Okay, so the question becomes like, can we teach any particular machine to see UI like a human? Okay, not just to detect any pixel differences, but it actually understand visual meaning, alignment, or any layout or spacing related issues, and it can proactively identify, and it will help to get it fixed as early as possible. So imagine if a system that inspects the user interface like a best designer, or it monitors it like the best tester, or it runs it across multiple browsers on multiple screens in different combinations. So automatically or intelligently, it will helpful for us to identify the visual drifts. Okay, so that's exactly the concept XB-VDD came in my mind, and as part of a ATGTR paper presentation, I have presented all these details. So an AI-driven cross-browser visual drift detector, it is designed to catch invisible issues which consider
So
the
Sachin, we are still
yeah.
seeing the title slide. Are you going
Yes,
to
yes,
wish?
yes. I'm
Hmm.
yes, yes. I'm jumping on to the next slide. But prior to that, I'm just creating a background, and then I'll just provide all the relevant details on these slides. Just a minute, Aditya. Yeah. So today I'm going to present how we can detect whatever has been automation are likely to miss, or maybe the scripts which are designed which can likely to miss, and the customers will never forgive if those uh, defects or those functional aspects we are missing on a browser or web-based applications which we are launching onto the browser. Okay. So uh, with respect to that, visual drifts are, I'm considering it as a mosquito. It is we cannot notice on our entire night, but it is ruining. It ruins our entire night. Okay, so cross browsers are cross browsers we can consider as like kids. Like testing on those cross browsers is like parenting the multiple kids. So let me jump on the actual slides. So before I begin. This presentation topic again, I'm highlighting it as a conceptual data and conceptual idea, not a developed framework. However, this idea is having a real business value, which is based on the AI driven mechanism. So it will definitely going to help spot the visual differences that our current functional testing may often overlooks. So let me jump on to the next slide. So these are the agenda points which covers QA blind spot, vision, the need of the XB-VDD, the key challenges we may face, how this framework idea can be implemented, the implementation approach, the business impact, way forward, and the benefits which we can take it from it as a takeaway. I'll jump into onto the next slide again. So this is high level agenda points. Okay, coming to the QA blind spot part as a visual drifts. So we can see like a one design with multiple browsers, and there are likely chances that multiple issues with the visual drifts we can experience. Okay, a small shifts in a user interface will create a major impact, and that will create a dissatisfaction to the end customer as well. Okay, so uh, these are the problems which we cannot ignore, and these are the QA blind spots. So let me start with a real situation, maybe which QA teams may face. A developer creates a clean flex-based layout, and it looks perfect on the Chrome browser, but on the Firefox browser, it has 4 pixel padding due to the box model interpretation, or maybe on Safari browser, it applies a font anti-aliasing differently. Okay, if we take the example of a Edge, it shifts the SVG icons by 1 pixel because of some rendering issues. So these are not bugs in your code. Okay, or these are not the bugs in the test cases designed by the QA. This is not the functional defect, but these are the visual drifts. Okay, and these visual drifts create, at certain point of time, it creates a impact on the customer. Okay, so why this becomes a QA blind spot? So document object model trees differ subtly across the browsers. This is the main reason. And the rendering engines do not follow the CSS spaces, that is cascaded style sheet spaces 100%, and that too uniformly. Okay. So font hinting varies by operating system. That too specific browsers are getting used on those respective operating systems. And the DPI scaling change per environment also a reason for a QA blind spot. Anti-aliasing algorithms that produces the micro differences, and the responsive breakpoints behaves differently on the different browsers. Okay, so if we take an example, if the manual testing cannot completely get scaled across multiple browsers, say suppose just as an example, if we check 4 browsers, there are 5 types of resolutions we are considering in our testing, and there are 3 particular themes. Okay, with different user roles which has been provided. If we take all these examples, there are bare minimum, I think, more than 100 visual states need to be tested by the manual tester, and there are likely chances that it may get missed from the manual testing for a particular visual drifts. It may create a very drastic impact on the customer, and at the same time it has a great possibility of revenue loss as well. So really it is really impossible to check manually all this stuff at a time. Okay, so if we take any particular example, let's just a hypothetical scenario we can consider. If in a BFSI model, if there is a loan calculator page is there, okay, on loan EMI calculator page, there is an input box which is shifted down on any X browser. We can take an example of a Safari browser. So with respect to that, if the user thought that the field is particularly disabled, or the field is not at all um, enabled to operate that particular box as an input. Okay, so the EMI submission will have a drastic drop, and that will create a revenue loss on that particular page just because of these visual drifts. Okay, so this is not a small issue. There is a revenue leaking through the pixels. This is one example. So overall, if we can see the fragmented browser ecosystem, manual checks which are completely unstable, business critical risk, inconsistent user experiences created due to the glitches, which reduces the usability, and the regression bottlenecks with inadequate traditional tools which we are using, which need to be improvised. So these are the certain QA blind spot, which are the reasons for the visual drifts. Okay, so for that we need an intelligent automation which can be driven using the AI, which can be a scalable and automated, so that it will ensure a pixel perfect and reliable consistent UI experience on multiple browsers. I'll jump on to the next slide. Okay, so next slide is with respect to precision vision for the front end battlefield. Okay, so if we consider today's web applications must render consistently. Definitely, it must render consistently across various browsers, and we are frequently or oftenly the end customer or the end users are using Chrome browser. Thereafter, they are preferring the Firefox. Thereafter, they may be preferring the Edge, and thereafter they are using the Safari. So if we can check onto the um, Google or maybe onto the uh, uh, chat gpt, we will get how frequently which browser is getting used, and there are certain reasons why that particular browser has been preferred by the end customer. Okay, so with respect to this precision vision for the front end battlefield, why I have highlighted this as a precision vision for the front end battlefield, because the first impression is the browser based impression where the customer is utilizing that for uh, his particular stuff to be done on that particular web page. Okay, so pixel difference tools are used to compare here uh, from the comparison perspective with respect to the two images which is getting used to compare, and it is highlighting every pixel that has certain changes. Okay, and browsers will produce natural pixel differences. So with these, with respect to anti-aliasing issues, font smoothing issues, or sub-pixel rendering issues. Okay, so traditional tools treat it as a one pixel aliasing. There are certain font weight differences can be also experienced. Operating system level smoothing differences are also experienced as a failures. And here, the QA teams drown in false positives. Okay, so here the tool which conceptually I thought like the XB-VDD, it thinks very differently. Okay, so it understands visual semantics, it detects deviations that matter, it ignores noise that doesn't considered earlier. So it answers the questions like: is the button still visually tappable? Is spacing affecting the readability? Did a layout break and affect the usability? Okay, so here we can see in the picture like manual UI checks followed by the AI powered analysis, which is automated part with the visual drift detection, and the scalable solutions which can be provided for the consistent UI based applications which can be experienced by the end customer on the any kind of a browser or the across any browsers, so that they will get the fast, accurate, and a scalable experience out of it. Okay, so if we can take any example over here, like any e-commerce product page which has a pixel difference identified, and that pixel difference can be effectively checked by the cross browser visual drift detector. Okay, maybe a pixel difference tools can identify more than 1,000 differences, but it should be meaningful. Here, the XB-VDD tool can flag the 12 meaningful deviations, which has a high impact with respect to the business, so that there will be very less revenue loss, and it can produce that particular application with respect to the more quality. Okay, so there will be an experience of a shifted price, misaligned CTA button can be aligned properly, and a truncated product name can be identified properly through XBVDD to improvise. Okay, so it will give the accurate detection with 90% noise reduction. So this is overall precision we can achieve. Jumping on to the next slide. Okay, so why do we need cross-browser visual drift detector? So with respect to this, I would like to highlight like there are certain key points we have considered, like fragmented browser ecosystem, manual and pixel by pixel checks, the business risk and the industries which are affected. It is not limited only to the IT sector, but the browsers wherever it is getting used, those are highly impacted. Okay, so we have highlighted here like BFSI domain, healthcare, e-commerce, telecom. At the same time, there are other industries also getting impacted. We can see e-commerce is the majorly impacted site where customers are daily dealing with any particular product which need to be added into the cart. If there are any differences, definitely it will create a bad impression on the customer or the end user, and definitely there would be a revenue loss or the business loss out of it. So if we see the core issues, why do we need the XBVDD? So from that perspective, if we see the fragmented rendering engine related issues, so the Blink and the WebKit, these are the tools used to handle these particular details. Okay, so they will use for checking the grid spacing or the typography or the image interpolation in a different way. Okay, the manual checks collapses under the scale. So those are used in the modern web applications which have nested components, conditional user interfaces, dynamic states, and the asynchronous content rendering details as well. So visual validation is not a 10-minute task. It's a multi-environment matrix. So it will take time, and the AI automation using XBVDD will be a value add. Now, if we check the business damage, which is non-trivial, so in BFSI, if we see a misaligned input can cause from the abandonment. In healthcare, we see like a shifted table column can miscommunicate lab values, and in e-commerce, a misplaced price or the CTA kills the conversion. Okay, it is directly impacting onto the amount of transaction done by the end customer or the end user, and tools aren't evolving yet. So legacy tools rely on certain things like pixel comparison, basic document object model differences to capture, and the image hashing as well. So they cannot interpret the semantic differences which is expected, and that can be easily achievable by this particular concept XBVDD. Okay, so if we take one example, um, a hypothetical scenario again. A telecom portal had inconsistent rendering of know your customer document preview. Okay, so pixel tools likely to flag thousands of differences. However, a specific issues like the zoom control overlapped that upload button exclusively on the particular browser, and it can only be traced by using this conceptualized tool, which is XBDD. Okay, moving on to the next slide. Okay, so this is a AI-driven framework as part of Visual Drift Detector has been designed. So if we see this XBVDD solution, it is around 7 component are there, and with respect to this, we can check like it is AI image comparison is the major part. There is a browser automation also considered along with the tools Playwright and Puppeteer. A smart drift tagging and heat maps are also associated with this particular XBVDD solution framework. The false positive reduction identification using machine learning and accuracy improvement, and cloud native like CI/CD integration, that is CI/CD pipelines, and the cloud deployments are also considered. So with respect to this, if we consider the browser automation layer over here, we use Playwright majorly. So it launches the four browsers in parallel, and it captures the deterministic screenshots. So it will ensure a viewport consistency and the dynamic noise via preprocessors that can be removed using the Playwright. Okay, this provides the raw visual data using the vision pre-processing layer. It helps to normalize the resolution, removes the dynamic document object model zones, stabilizing the anti-aliasing issues, and auto crop meaningful regions. Next one is the CNN based drift detection layer. Okay, this is where XBVDD becomes more powerful, I would say. So as part of this particular framework, the XBVDD model detects the component existence, deviation, typography related part, layout collapses related part, alignment shifts, spacing drifts, everything, and the rendering regressions which is not identified over the last couple of releases maybe. So it works like a trained human eye but faster and more consistent, so efficiency can be gained. Then a semantic classification and a scoring layer. This each drift is classified, severity scored, usability ranked, and grouped by a certain components, and that is mapped with the UI functionality as well. So instead of 100 differences, we will get a button alignment deviation on particular browser with high severity, which has a high impact on any particular flow. Say suppose a checkout flow is there, and that has a high impact on the revenue, that will be potentially identified first in the semantic classification, and it will be highlighted to the uh, during the defect, so that it will be fixed earlier, and there will be the less impact on the end customer. Okay, so moving on to the next slide. Okay, so these are the key challenges considered as part of XB-VDD. Okay, so with respect to the key challenges, I would like to highlight like these are real engineering challenges. So flakiness from the dynamic content, so promotional banners, user profile pictures, rotating carousels. So all these are the flakiness from the dynamic content. So XB-VDD learns and masks them automatically. Okay, and next one is like the false positive from the pixel based tools. The reduction in the noise through perceptual hashing, smoothing normalization, and AI based tolerance learning can be achieved using the XB-VDD tool. And the incorrect baselines, okay, as part of incorrect baselines, the legacy tools fail when UI updates frequently. Okay, so they need to be trained so that the updates can be handled properly. And here, the cross browser visual drift detector, this uses the baseline evolution, not just a static snapshot, but a dynamically observed things which can be updated frequently, and where legacy tools fails usually. So XB-VDD helps to correct those particular baselines by capturing those details dynamically. Now, if we see the slow continuous integration feedback loops, those are also play a crucial role here. So visual test often slows down in the pipelines, and the paralyzed runners. So paralyzed runners speed up detection by 3 to 5 times here in the XBVDD. Okay, and the lack of actionable reporting. So instead of a red blob, or we can get a metadata rich report, which consists of drift type, probable cause, and the severity related details, impacted component, impacted journey as well. Okay, so example here we can consider it as like a BFSI client reduced drift triage time from 3 hours to 11 minutes. Huge difference. It can be achieved. So these are the key challenges. Moving on to the next slide. Okay, so with respect to the business impact, the vision and the value we
Sachin, we lost you. Are you there?